Welcome back to the deep dive, to you, the learner. We are so glad you are joining us today. If you were to just hold up a simple piece of stiff cardboard-like, maybe the size of a modern dollar bill, covered in this weird grid of little rectangular holes, you wouldn't necessarily think you were looking at a weapon of cultural revolution.
Right, no, it just looks completely inert, like just some obsolete office supplies from a bygone era or something.
Exactly. You'd probably just see a piece of trash. But as we were digging through our sources today, we realized something wild.
Oh, totally.
We're looking at a deeply detailed historical report on early computing, plus this fascinating cultural paper on the societal shockwaves of the 1960s. And it turns out, this little piece of punched cardboard is actually the missing link.
Yeah, it really is. It is the physical bridge between ancient textile arts, the dawn of modern computing, and honestly, the very first time society experienced a collective panic over what we'd now call big tech.
Right. Okay, let's unpack this because the central premise here is just mind-blowing to me. We're looking at how a physical method for making luxury fabric didn't just give birth to the information age, but actually triggered this profound cultural anxiety about, algorithmic dehumanization.
It's an incredible trajectory. I mean, we are taking a technology designed to weave flowers into silk, and we're watching it evolve into a system that categorized human beings.
Yeah.
For better and, well, definitely for worse.
Yeah. And to understand how we got there, we really have to go back to the very beginning of the technological timeline. Because long before we were processing data, we were processing luxury fabrics.
We actually have to start in China for this. So according to folklore, around 2700 BC, the Chinese empress Xilin Shi was having tea in the imperial gardens.
As you do.
Right. And a silkworm cocoon just happens to fall from a mulberry tree right into her steaming teacup.
Wow.
Yeah. And when she pulled it out, she discovered the heat had softened it, and it unraveled into this incredibly strong, just impossibly fine thread.
The ultimate happy accident. I
Yeah.
love that. And I mean, whether that specific teacup story is entirely true or not, the archaeological evidence does show silk weaving in China dating back thousands of years.
Oh, yeah. They had a global monopoly on it.
And they fiercely guarded the secret, right?
Yeah.
But eventually, the method made its way along the Silk Road to Europe, and by the 1700s, Lyon, France, had become the absolute undisputed capital of dress silk in the Western world.
But there was a massive bottleneck in Lyon at the time. The European nobility had this skyrocketing demand for intricate, beautiful French silk, but the technology to produce it was just agonizingly slow.
Because they were using something called a draw loom, right?
Exactly, the draw loom.
I was trying to visualize this from the historical report, and honestly, it sounds like a logistical nightmare.
Oh, it was brutal.
It wasn't a solo operation at all. It required two people. You had the master weaver sitting at the bottom doing the actual weaving, but then you had a second person, usually a young boy, called a draw boy.
Yeah, literally perched precariously on top of this massive wooden loom.
And his job was incredibly physically demanding. Like to weave a complex pattern, say, I don't know, a floral brocade, the draw boy had to physically hoist up very specific groupings of warp threads. Those are the long, lengthwise threads.
Right, he lifts them up, and that creates a gap so the weaver down below can pass the colored weft thread through.
And then for the very next millimeter of the pattern, the boy has to drop those threads and heave up a completely different, really heavy cluster of threads.
Exactly the problem. Every single row of a complex design required a different arrangement of threads to be lifted. And because silk is so fine, even a highly skilled two-man team, working perfectly in tandem until their hands literally bled, could only weave about 1 inch of brocade in an entire working day.
1 inch.
1 inch.
A full day of manual labor for 1 inch of fabric. That is wild. So naturally, the incentive to automate this process was just astronomical. Now, the report mentions that Joseph-Marie Jacquard eventually solved this, but I was actually shocked to see he didn't invent the concept out of nowhere. Like, who were the guys before him trying to crack this code?
Well, it was a whole century of trial and error before Jacquard. Back in 1725, a French textile worker named Basile Bouchon had this brilliant insight. His father made automated organ, music boxes, essentially.
Okay.
And Bouchon realized he could use the same perforated paper tape that controlled organ music to control a loom.
Oh, wow.
Yeah, he recognized that the holes in the paper tape were actually a form of stored information.
That is so smart.
Yeah.
But paper tape in a heavy industrial loom seems like a recipe for disaster. Like, wouldn't it just tear constantly?
It did. It tore all the time. So a few years later, his coworker Jean Falcon upgraded the system. He replaced that fragile, continuous paper tape with durable, rectangular cardboard cards that he laced together in a chain.
Okay, so getting closer to the punch card.
Exactly. Then, in 1745, another inventor named Jacques Vaucanson came along and tried to make it fully automated. He put a perforated paper roll on a mechanical cylinder, basically attempting to get rid of the drawboy entirely.
Let me guess, it didn't work.
Oh, not really. His design was way too complex, very prone to breaking, and it just wasn't commercially successful.
So it basically took another half century for the definitive breakthrough.
Right. And what's fascinating here is that Joseph Marie Jacquard in the early 1800s was the ultimate synthesizer. He studied Bouchon's paper, he looked at Falcon's chained cards and Vaucanson's cylinder, and he basically engineered the definitive commercially viable version.
So he brought it all together.
Exactly. Jacquard used a square cylinder at the top of the loom draped with Falcon's chain punch cards, and he created this brilliant, highly robust hook and needle system.
Okay, wait. How exactly did that hook system interact with the cardboard? I want to make sure I'm picturing this right.
So the cylinder presses a punched card against a matrix of spring-loaded needles. If there is a hole in the card, the needle passes straight through, right? Which then allows a hook to grab a thread and lift it up.
Gotcha.
But if the card is solid cardboard at that spot, the needle is blocked, the hook is pushed out of the way, and that specific thread just stays down.
Okay, I want to pause here because this is where the genius of it really clicked for me. To put this in modern terms, this is essentially early pixel art.
Yes.
Right? Instead of drawing a screen frame by frame, the Jacquard loom was rendering images thread by thread. Those punch cards were the binary code.
Exactly.
Like a hole meant the pixel was on, and solid cardboard meant the pixel was off.
That is precisely the mechanism. And the results were staggering. The speed of weaving complex silk went from 1 inch a day to 2 feet a day.
2 feet. But, you know, the real breakthrough isn't just the speed, is it? Like, think about a traditional music box. The metal cylinder with the little bumps on it is hard-coded to play exactly one song. If you want a different song, you have to build a whole new music box.
Right.
What Jacquard did was separate the machine from the instructions. The loom is the hardware. The stack of punch cards is the software. You don't have to rebuild the loom to weave a different pattern. You just swap out the deck of cards.
I mean, you've just described the fundamental architecture of modern computing right there. But at the time, in Lyon, it was just seen as this terrifying disruption.
Oh, for sure.
As with all major leaps in automation, it was met with fierce resistance. The master weavers and the drawboys were terrified of losing their livelihoods to this, this software.
Yeah, the sources said they literally dragged Jacquard's machines into the town square and smashed them.
They did. It is a very early, very violent preview of the modern automation anxiety we still see today.
But the efficiency was undeniable, and the Jacquard loom eventually conquered the textile world anyway. So Jacquard proves that holes in a card can control physical threads. But how do we get from weaving silk to calculating numbers? Because those feel like two completely different universes to me.
They do, but we bridge that gap in Victorian England with a brilliant but notoriously cranky mathematician named Charles Babbage.
Cranky is a good word for him based on the reading.
Very cranky. So in the 1820s, Babbage was deeply frustrated by the logarithmic and trigonometric tables of his era. Navigators, engineers, bankers, they all relied on these printed books of numbers, but they were calculated by hand, by humans, and they were just riddled with human errors.
And a bad math table isn't just an inconvenience. It means a ship crashes into a reef or a bridge collapses.
Precisely. The stakes were high. So Babbage wanted to remove the human element entirely. He designed this massive mechanical calculator called the difference engine, which was composed of thousands of precisely machined brass gears.
And the British government basically gave him a blank check, right?
Well, a small fortune, over £17,000, which was an astronomical sum back then, but the project was a total disaster. Babbage kept changing the design, he fought constantly with his chief engineer, and the machine was never actually finished.
But Babbage doesn't give up. Instead of scaling back after failing, he actually pivots to something infinitely grander. He conceptualized the analytical engine. And the sources are very clear on this. This wasn't just a calculator. This was the blueprint for the first general-purpose programmable computer.
Yes.
It had a store, which is what we call memory today, and it had a mill, which is exactly what a modern CPU does.
But the immense hurdle Babbage faced was input. How do you feed complex instructions and variables into a room-sized, steam-powered machine made of brass gears?
And this is the Jacquard connection.
This is it.
The story goes that Babbage acquired a portrait of Joseph Marie Jacquard. But it wasn't a painting. It was woven entirely in black and white silk on a Jacquard loom.
And it was a masterpiece of textile engineering. The shading and detail were so hyper-realistic that people frequently mistook it for a fine engraving. It required 24,000 individual punch cards to weave.
Wow. And so Babbage looked at this silk portrait and just had this massive leap of imagination. He realized that if punched cards could tell a machine how to weave an image as complex as a human face,
Right.
they could tell his analytical engine how to process numbers.
The mechanical logic is completely identical. Just as a hole in a Jacquard card allowed a hook to lift a thread, a hole in Babbage's card would allow a mechanical pin to drop through, which would then engage a specific lever, which would turn a specific gear in the mill to add or subtract a number. Babbage even categorized his software. He designed operation cards to tell the machine what math to do, variable cards to tell it where to fetch the numbers from the store, and number cards to input the raw data.
That is just brilliant. And we have to talk about Ada Lovelace here, because Babbage didn't flesh out this theory alone.
No, she was vital.
She was the daughter of the poet Lord Byron, and she possessed this incredibly rare combination of rigorous mathematical brilliance and soaring poetic imagination. She translated a French paper about Babbage's engine and added her own extensive notes to it.
Right. And those notes actually contained the very first computer algorithm ever. It was a step-by-step sequence of operations for calculating Bernoulli numbers. But Lovelace saw way beyond pure calculation. She understood that the machine could manipulate any symbol, not just numbers, but potentially musical notes or letters, if they were converted into rules the machine could understand.
She really captured the absolute magic of this conceptual leap perfectly. In the source material, there's this famous quote from Lovelace where she says, and I love this, "The analytical engine weaves algebraical patterns just as the Jacquard loom weaves flowers and leaves."
Beautiful.
It's just a beautiful way to explain abstract processing.
It perfectly bridges the two worlds, but, there is a profound tragedy to the Babbage and Lovelace story. The analytical engine was never actually built during their lifetime.
Yeah, that part is so sad.
Babbage lacked diplomacy. He completely alienated his government funders, and frankly, he was working with Victorian machine tools that really struggled to manufacture gears with the microscopic precision his designs required. So Babbage had the right hardware concept, and Lovelace had the right software concept, but they were simply a century too early.
They were too early, sure. But the world didn't stop generating numbers while they waited. Fast forward to the end of the 19th century, and the United States was facing a literal data crisis. We were just drowning in information.
We really were.
The 1880 U.S. Census had counted nearly 32 million people, and it took an army of clerks over 7 years just to tabulate the results by hand.
It was tipping into a constitutional crisis. The U.S. Constitution mandates a census every 10 years to apportion political representation. They were looking at the pending 1890 census, projecting population growth, and realizing they literally would not finish counting the 1890 data before the 1900 census began.
Oh, man.
The math was completely breaking down, and they desperately needed a counting machine.
Enter a young statistician named Herman Hollerith. The government holds a contest to find an automated tabulating system for the 1890 census, and Hollerith wins handily with a system that completely relied on punch cards.
And the mechanics of Hollerith's system are brilliant because they finally transition us from mechanical gears to electricity.
Oh, right.
Yeah. Census data, things like age, gender, occupation, was recorded by a clerk punching specific holes in a standardized 3x7-inch cardboard card. The tabulating machine had a press with spring-loaded metal pins pointing down, and underneath the card were tiny cups filled with liquid mercury.
Okay, so when the press comes down on a card, the solid cardboard stops the pins. But where there is a punched hole, the metal pin drops straight through the cardboard, dips into a cup of mercury, and completes an electrical circuit.
Exactly. And that flash of electricity triggers an electromagnet that advances a dial counter by exactly 1 digit. It's the Jacquard binary on-off system, but weaponized with electricity.
That's wild.
And it worked flawlessly. The 1890 census was tabulated years faster than the previous one, saving the government an estimated $5 million. Hollerith was so successful, he founded the tabulating machine company.
But hold on. Here's where it gets really interesting regarding Hollerith's inspiration. If you look at the official history, Hollerith always claimed he got the idea for punch cards from watching a train conductor punch tickets.
Oh, yes.
Yeah.
The ticket story.
Yeah. He said conductors would make a, quote, punch photograph of a passenger punching a hole for hair color or gender so people couldn't share tickets. He never gave any credit to Jacquard or Babbage at all.
Right, that is the folksy American origin story he loved to tell the press.
But our sources point out a detail that changes everything. Hollerith's own brother-in-law was actively working in the silk weaving business. They were documented as having conversations about weaving technology. Are we really supposed to believe this genius inventor talking to a silk weaver had no idea how a Jacquard loom operated? That feels highly suspicious to me.
I completely share your skepticism there. Innovation rarely happens in a vacuum, and it almost never happens via a trained conductor when the exact industrial solution already exists in your family's trade. Whether Hollerith admitted it or not, the DNA of his Census machine was French silk.
And Hollerith's company goes on to shape the entire 20th century. Through a series of corporate mergers, his tabulating machine company eventually becomes Computing Tabulating Recording Company. In 1924, it is renamed International Business Machines, IBM.
Yep. And under the leadership of Thomas Watson Sr., IBM became a monolithic powerhouse. Watson instilled a massive, intense corporate culture. They had the famous Think motto plastered everywhere, mandatory dark suits and white shirts for salesmen, company songs. I mean, they even had the 100% club for sales quotas. IBM essentially built the data infrastructure of the 20th century.
And they finally closed the loop on Babbage's dream, didn't they? In the 1930s and 40s, a physicist named Howard Aiken approached IBM to build the first general-purpose programmable computer, the Harvard Mark III. He used IBM's money and IBM's engineering. And unlike Hollerith, when Aiken wrote his proposal, he explicitly cited Charles Babbage, Ada Lovelace, and the Jacquard Loom.
It was the culmination of a centuries-long technical evolution. The basic premise of the Jacquard card hole versus no hole had seamlessly transitioned into the electrical on-off switch. But for decades, these machines, Hollerith tabulators, and early IBM computers were massive, incredibly expensive pieces of equipment hidden away in the back rooms of government bureaus and corporate headquarters.
Exactly. They were tools for the elites.
Yep.
But eventually, this massive data infrastructure had to interact with everyday people. And that brings us to the 1930s, the New Deal, and the moment the punch card goes public.
Right, the turning point.
Government agencies like the Agricultural Adjustment Administration and the Social Security Board started issuing actual checks printed directly onto punch cards. And by the 1950s, your utility bills, your department store invoices, your tollway passes, they were all arriving in the mail as punch cards.
And this created a massive logistical problem. The public was now physically handling the interface of this corporate computer system. But the tabulating machines were delicate and highly calibrated. If a card was creased, torn, or damaged, it would jam the machine or cause a misread. So IBM and these corporations had to print stern warnings on the cards themselves to train the public on how to handle them.
And that warning became an absolute cultural phenomenon.
Oh.
The canonical phrase printed on millions and millions of cards was, "Do not fold, spindle, or mutilate."
It was ubiquitous. Everyone knew that phrase.
Now, I have to ask on behalf of anyone listening who didn't work in a mid-century office, what on earth does spindle mean?
Right. It refers to an old analog filing practice. A clerk or a restaurant cashier would have an upright, sharp metal spike sitting on their desk, a spindle.
Okay.
When they finished processing a paper receipt, they would just slam it down, impaling it onto the spike. When the spike was full, they'd run a string through the holes and file the stack away.
Oh, but impaling a punch card on a spike would punch a brand new random hole into the cardboard.
Exactly.
Which would completely change the binary data on the card and ruin the calculation.
Yeah.
So no spindling.
No spindling.
But the word that really jumps out to me is mutilate. Do not fold, spindle, or mutilate. That is such an aggressive, intensely emotional word to put on a simple gas bill.
It is remarkably aggressive, and if we connect this to the bigger picture, it reveals a profound power dynamic. It suggests these massive corporations were genuinely afraid that everyday people would take out their economic frustrations directly on the cards.
Wow.
The public was being explicitly conditioned to respect the machine, to conform their messy human behavior to the rigid needs of the corporation. The punch card had literally become the tangible physical boundary between the individual citizen and a massive, faceless bureaucracy.
And people deeply resented that boundary. That underlying friction between human and machine really boiled over in a huge way in the 1960s. The punch card stopped being just a delicate utility bill and became a lightning rod, a symbol of everything wrong with modern, automated, sanitized society. And we see this explode at the University of California, Berkeley during the free speech movement.
Oh, absolutely. The university administration at Berkeley relied heavily on punch cards for processing class registration. To the thousands of students feeling lost in this massive system, that little piece of cardboard became the ultimate symbol of alienation. They felt they were being processed and sorted by what they called the IBM pattern of education.
So they started subverting the symbol. Students would pin blank punch cards to their shirts and wear them as name tags to protest being treated like anonymous numbers in a database. It tied right into the counterculture pop media of the time, like that British sci-fi TV show The Prisoner, where the main character constantly shouts the catchphrase, "I am not a number, I am a free man."
Right. Right. And the protests quickly escalated from metaphorical subversion to physical destruction. Students began setting fire to their punch card registration forms in massive crowds, literally the exact same way they were burning their draft card.
And some students, honestly, the absolute legends of the era, figured out how to weaponize the cards against the university.
This part is wild.
Right. They would get access to the campus card punching machines.
Yeah.
And they would intentionally punch obscenities into the cards, or punch words like strike. Then they would secretly slip these corrupted cards back into the massive stacks. When the administration ran the registration lists through the tabulators, the machines would jam, or the high-speed printers would start spitting out profanity.
It's brilliant.
Think about the mechanics of that for a second. Punching obscenities to jam the mainframe is basically the 1960s equivalent of a hacker doing a SQL injection or a DDoS attack today. They were using the system's own binary language to break the system.
It was a highly sophisticated form of sabotage. And it was during these very protests that Mario Savio, one of the key leaders of the free speech movement, gave his most famous speech on the steps of Sproul Hall. He told the gathered students, "There is a time when the operation of the machine becomes so odious that you've got to put your bodies upon the gears and you've got to make it stop."
And when you hear that quote today, you naturally picture a gritty factory line. You picture industrial steel gears. But the cultural sources we read point out something profound. He wasn't just using a factory metaphor. He was directly, explicitly protesting the information machine. He was talking about the computer.
That's right. The fear of being abstracted into a two-dimensional piece of cardboard was palpable. And as we discuss this, we do have to impartially acknowledge the much darker historical reality that our sources bring to light here.
Yeah, we do.
While American college students in the 60s were annoyed by the anonymity of university registrars across the Atlantic, the punch card carried an infinitely more terrifying legacy.
Yes, the historical report details how Nazi Germany utilized Hollerith machines extensively. They used IBM-designed tabulators in their national censuses to efficiently track and sort citizens by religion and national origin. And the sources confirm they even installed and used Hollerith tabulating machines at the Treblinka death camp to maintain precise, mechanized records of the prisoners.
It's horrific. And because of that horrifyingly lethal application of data processing, there was a massive visceral backlash in Europe during the 1960s and 70s against census taking and centralized state record keeping. The American reaction, these counterculture college pranks and pop culture jokes about folding and spindling, was a uniquely American privilege. In Europe, the punch card didn't just represent bureaucracy. It represented the violent, catastrophic power of the surveillance state.
So what does this all mean for the people living through the dawn of the computer age? Regardless of the continent, it was this pervasive, creeping dread of human identity being reduced to raw data.
Which raises an important question about how society instinctively tries to reassert its humanity when faced with cold, calculating technology. You actually saw this psychological pushback play out in consumer advertisements during the 1960s.
Oh, really?
Yeah. When computer matchmaking and early computer dating first became a novelty fad, the advertising agencies explicitly tried to soften the technology. They would run magazine ads featuring illustrations of Cupid shooting his arrow directly through a standard IBM punch card.
Oh, wow. So Cupid is literally mutilating the card.
Exactly. The advertisers were symbolically mutilating the data to send a comforting message. They were basically saying, don't worry, human love and human emotion are still more powerful than the machine's algorithm.
That is an incredible visual. So to pull all of these threads together, we have gone on quite the journey today.
Yeah.
We started with the ancient legend of Empress sealing cheese teacup, moving to the incredible pixel art woven by Jacquard's silk loom in France. We saw Charles Babbage stare at a woven portrait and dream of a computer. And we saw Herman Hollerith use those exact same holes to count a nation, birth IBM, and industrialize information. And finally, we saw those little cardboard cards become the literal flashpoint for a cultural rebellion at Berkeley.
And while the physical punch cards themselves largely faded away in the 1980s, eventually replaced by magnetic tape, floppy disks, and now the cloud, the fundamental architecture hasn't changed one bit. That Jacquard binary concept of whole or no hole seamlessly evolved into the electrical ones and zeros that remain the absolute, undisputed bedrock of all computing today.
Which brings us to a final thought we want to leave you with, something to mull over after you finish listening today. The physical punch cards are gone. We no longer hold a piece of cardboard in our hands with a printed corporate warning telling us not to fold, spindle, or mutilate our data. But today, our lives are processed, tracked, and sorted by invisible algorithms that are infinitely more powerful and pervasive than the Harvard Mark I. So if a college student in the 1960s felt profoundly alienated and dehumanized just by registering for classes with a piece of cardboard, how much of our human complexity is currently being mutilated right now simply to fit neatly into the massive databases of modern tech giants?
It's a question that only gets more urgent the deeper we move into the information age.
It really does. Thank you for joining us on this deep dive. Keep questioning those invisible systems around you.